This is a quick introduction video about the idea of identifying how to find the length of an arc. So we see our arc right here in blue. Okay. It's part of the function f of x equals 4 minus x squared. And we know that this is a parabola which opens down and has an x-intercept at -2 and 2 and the y-intercept at 4. And we're interested in this particular zone from point A to point B, where A is x equals -1 and B is 1.5. So what's the length of this arc? Right? Well, we don't have anything for that yet, but we do know the length of a line segment. That's our distance formula. So if we actually increase the number of intervals, we're going to increase it to 1. So we're going to find the distance, that line right there, which we can absolutely do because we have our x coordinates and we can plug them in and we get our y coordinates. And we actually can, using the distance formula, we find out the length of that line right there is 2.8. Now, it's an approximation for the length of the arc. It's not all great, but it is at least a starting point. So how do we make it better? Well, what if instead of having a single line that connects from A to B, we have two lines? One which hits the region about halfway, right about there, and the second one that takes care of the second half, like so. Now I've got two lines, and I can find the length of this segment and the length of that segment. Right? This segment goes from A, x equals A, to x equals the midpoint between A and B, and this one goes from the midpoint between A and B to B. Now we see that we're up to 4 as our arc length. Now it's still not all that close because we have a nice arc here as opposed to these line segments. So while 2 is better than 1, what if we were to increase it again to 3? Can you see what's happening here? As we have more and more line segments, we have a closer and closer approximation to the actual length of the arc. Just at 5 line segments, there's not a huge difference between the red line segments and the blue arc. And we can see that we're at 4.267 now. And we can continue to increase, and the more we increase, the more accurate you get. We see that we are up over 4.3 at this point with 14 line segments. Well, what would be an ideal number of line segments? Obviously, 14 is better than 4, which is better than 2, which is better than 1, and the best amount would be an infinite number. All right. We want to add up the distance of all those line segments, and that would give us the length of the arc. And that's where we're heading with arc length.